In the previous video, we discussed how to evaluate sine of t and cosine of t when we know the terminal point TP of the reference angle t prime. Essentially, what we had to do was we had to find the terminal point for t prime, and let's call that a comma b. Then we had to use the fact that the terminal point for t is plus or minus a comma plus or minus b, where you choose plus or minus based on the quadrant. So based on the quadrant. And of course, for reference, in the last problem, t was 7 pi over 6, and we found our reference angle to be pi over 6, and that made it so our terminal point for the reference angle, pi over 6, this is something you have to have memorized. This is going to be root 3 over 2, comma 1/2. And earlier we had concluded that in our problem for t equals 7 pi over 6, that 7 pi over 6 was in quadrant 3. And in quadrant 3, both the x and y coordinates are negative, so we chose negative for both of these. Then finally, once we have the terminal point, we simply chose the x coordinate to be cosine of t. So cosine of t will just be the x coordinate, in this case negative root 3 over 2, and sine of t was the y coordinate, negative 1/2. In this general strategy of finding the terminal point for t prime, then using the fact that the terminal point for t is the same almost up to a plus or minus sign as the terminal point for t prime. And then finally, using the fact that cosine of t is the x coordinate and sine of t is the y coordinate for the terminal point, will always work as long as you know what the terminal point for the reference angle is. So the previous method works. As long as you know the terminal point for t prime. So we can evaluate the trigonometric functions cosine of t and sine of t as long as we know, and I should say evaluate them by hand, as long as we can find the reference angle, and the reference angle has a terminal point that you know. However, it is important to note that cosine of t and sine of t have domain all real numbers, minus infinity, comma infinity. I think a common misconception is students tend to think that sine of t and cosine of t can only be evaluated, these two functions can only be evaluated if t happens to be some special angle. However, that's not the case. Something like cosine of 21 degrees. 21 degrees is in the first quadrant, it has reference angle equal to itself. Now we don't know the terminal point for 21 degrees, so that means we can't evaluate this by hand, but this still exists. That is, there is still an output for cosine of 21 degrees. You, at this point, would have to use a calculator to be able to get a decimal representation of it. It would be something like 0.9335. So just because an angle is not, or does not have reference angle equal to a special angle in that first quadrant, something like pi over 6, pi over 4, pi over 3, doesn't mean the trigonometric functions of such an angle doesn't exist. They in fact do, and that's what this statement says. Cosine of t and sine of t have domain all real numbers. So another example, sine of 1 radian. If you do not put a symbol here, it's assumed to be 1. 1 radian, that actually also lies in the first quadrant, and you can know this because 1 radian, well, it's definitely bigger than 0, and pi over 2 is approximately equal to 1.5. Remember, pi is 3.14, so pi over 2 is about half that. So 1 is between 1 and 1.5, so that is in the first quadrant. So its reference angle is itself 1 radian, has reference angle 1 radian. And so this exists as a real number. That is, you can plug 1 radian into the sine function. However, the output is not something that you can generate at this point by hand. In a calculator, it ends up being 0.8415. Now that we have the domain of the cosine and sine functions sorted out, let's talk a little bit about the range. And I think in order to understand the domain and range, as with understanding most things about trigonometric functions, it's useful to draw a unit circle. So let's go ahead and do that. And let's go ahead and draw an angle in, why not, third quadrant. Now I should make clear that this circle that I've drawn is in fact the unit circle, so this tick mark on the x-axis is 1, and this is also 1, since the radius, that is the distance from the center to the edge of the circle, is 1. And let's mark the terminal point for this angle that I've drawn. We'll call this angle T, and the terminal point x comma y. And we know that the domain of sine of t and cosine t is all real numbers. And let's talk a little bit about why that's the case. The reason is that there's no restriction on this t here. T could be anything. For any t that you give, you can draw an angle in the xy plane. You can draw the terminal point on the unit circle, and you're able to get the x and y coordinates for that particular angle. So that means that the domain is all real numbers. Now, what about the range? That is, what are the possible outputs of this sine of t and cosine of t? Let's start with cosine t. Now remember, cosine of t in my drawing here is x, and let's think about what the largest and smallest possible values for x could be. So if you start thinking about different angles and drawing them in our plane here and their terminal points, let's see if we can't draw a dot there, and start thinking about, well, what's the maximum x could be? Well, our terminal point has to lie on the unit circle. And thus, we couldn't have a terminal point somewhere out here, right? Because, well, this doesn't lie on the unit circle. So what's the terminal point that's farthest to the right? Well, that would be 1, 0. That is, the largest that the x-coordinate could be is 1. And for a similar reason, the smallest the x-coordinate could be, would be -1 at the terminal point -1, 0. And so that means that the range of cosine of t is all the numbers between -1 and 1, and including -1 and 1. Why is it all the numbers? Because any x value you pick between -1 and 1, say 0.6, so 0.6 is about here, has a terminal point that lies on the unit circle. And so the range of this is going to be -1, 1. A very similar argument, except switching the x values for y values, tells you what the range of the sine function is. So what is the terminal point on the unit circle with the maximum y value? Well, that would occur at the very top of the unit circle. That's 0, 1. The maximum y value is positive 1, and similarly, the minimum y value is going to be negative 1. So that means that the range of sine of t is negative 1, 1 as well. And that concludes the discussion about determining what the domain and range of the sine and cosine functions are.